Today I want to show you how to sketch the graph of exponential functions using transformations. We start with identifying the parent function. In this case, it appears to be y equals 1 over e to the power x. So the base is 1 over e. E is the number, which is approximately 2.72, and we take the reciprocal, that's a number less than 1. And we know for exponential functions with base less than 1, the graph is going to be a decreasing curve like this, passing through 0, 1, with horizontal x-axis being the horizontal asymptote. So next, we're going to sketch the graph of this exponential function based on the graph of the parent function. Step number 1, we'll shift the parent function to the right by 1 unit, because in our exponential function we have 1 subtracted from x. So that's going to give us a graph for y equals 1 over e to the power x minus 1. I want to keep track of some key point here. So that key point is going to be the y-intercept of my parent function with coordinate being 0, 1. With this shift, it will move to this new point with coordinate being 1, 1. And the profile stay the same, and the horizontal asymptote stay the same. So that's going to be what the curve looks like after step 1. So next step, I'm going to reflect the curve we get in step 1 across the x-axis. So the formula for that function is going to be y equals negative 1 over e to the power x minus 1. Because this negative sign is applied to this entire function from the previous step, that's translate into a reflection across the x-axis. Again, I want to keep track the key point. Previous step, it is located at this point with coordinate being 1, 1. After the reflection, the coordinate at that point is going to be 1, negative 1. Okay, so this is a new location of the point I have been keeping track of. And every single point on the graph of the previous function has to be reflected in the same fashion. So that's give us this curve here. So still the horizontal asymptote is x-axis. So the next step, we're going to shift the graph we get in step 2 upward by 1 unit. So that's going to give us the graph of the exponential function that is given to us. So our key point from the previous step is located at this point with coordinate being 1, negative 1. After the shift, it will be moved up to 1, 0. Okay, so this is a new location of the point I have been keeping track of. And the horizontal asymptote will be moved up by 1 unit as well. The equation for the horizontal asymptote is going to be y equals 1. Every single point from the previous step is going to be moved up in the same fashion. The profile doesn't change. This is the new location of the curve. Okay, and that's it. That's the sketch for the exponential function that is given to us in this problem. We're not going to look at the features under microscope, but some of the key features is there. As I said, we did keep track of the key point, which is the y-intercept of the parent function. And then we keep track of the location of the horizontal asymptote. Eventually, after all these transformations, is going to be located at y equals 1. And the shape of the curve is going to be correct, but some of the other features may be slightly off. For example, the y-intercept of the final function may not be where it exactly supposed to be, but overall the main features are good.